All right, we're going to get started. It's 2 minutes past the time. We welcome everybody to the San Francisco Dynamo user group. We have a special edition today because we are featuring Håvard Vasshaug directly from Norway. Håvard, you are on the line, right? Do you hear me?
I can hear you, yes. Can you hear me?
Yes. So we have a group of about, we expect to have a group of about 35, 40 people. We're going to get started with some announcements, and I'll hand you over the control. Just a few announcements for this forthcoming month. We have made some changes in our blog, so feel free to check those out. We have now Twitter reporting. We have a way for you to follow us via subscription email. So make sure you subscribe to our website to get the latest announcements on speakers. We are also planning to display a new calendar showing what's coming up in the next year. We are working with a volunteer committee to make these presentations better and have great speakers. The group is going to Las Vegas for Autodesk University. So December meeting is going to be in Las Vegas. If any of you here is planning to go, feel free to meet us at Augie. The annual reception is on Wednesday, December the 2nd. And we're always looking for great speakers. So if there's anyone who have interested on exposing their knowledge in the group, email to the email you see on the screen, sfdug_coordinator@gmail.com. I also want to thank Ideate Inc. for their sponsorship of food and beverages. And like I mentioned to Håvard, we owe you lunch, so sometime in the future, I'll pay for it.
Yeah, I'll let you know when I'm coming to San Francisco. I'll get that lunch.
Awesome. So the title of the presentation is Dynamo for Architectural and Structural Projects. Håvard Vasshaug is the design technologist for Snøhetta. He has a large trajectory of Dynamo use, and his talks and presentations are well received and well known worldwide. He's going to give us overlook of his projects utilizing computational design techniques. And with that say, I'm going to pass over the controls to Håvard. Håvard, I'm going to mute the people on the phone to avoid undesirable noise. But if there is anyone who has any questions, please type it on the chat panel, and we will read it at the end of the presentation. All right.
Okay. I don't know if the audio is only coming from you now, from your room, but there is some noise that I can hear. So
I'm going to mute myself.
If you want to mute the phone caller, that's all right with me.
Okay.
The phone caller, sorry.
I'm going to make sure we see your line, and I'm going to mute myself.
Cool.
So
it says now that I'm presenter. Can you see my face?
I believe you have to click share my screen.
Okay, let's see.
There you go.
Okay. Hey.
All right, I'm going to mute us. If there's a need to connect, I'll click the mute button again.
Cool. And just to confirm, you can see my slide number 1 with my face now, right?
I see. We all see your wide smile. Okay, I'm going to mute myself.
Okay, cool. Thank you. So let's start. This will be I've been looking very much forward to this. Thank you for inviting me. So right now I can hear absolutely nothing, and it feels like I'm talking to myself or talking to my computer in my second living room. I have my pajama on. It's 9:00 p.m. The kids are asleep. Wife is out of house, and I'm talking to myself. Only the thing is that like 50, 60 people are listening to me. So I hope you'll enjoy this. It's not a well-prepared presentation. It's just a recap of things that I have used Dynamo for on real architectural and structural projects the last 2 years, really. 2 years ago, my friend Julien Benoit in France told me after RTC Europe in Delft that I should learn Dynamo, and I always listen to what the man has to say. So I started learning Dynamo 2 years ago, and approximately at the same time, I started trying it out on different projects at the company that I was working at the time. So first of all, I'm Norwegian. I'm based in Norway. I live in Oslo. I work in Oslo. The logo that you see on this slide is Snøhetta logo. That's the name of my company. We are based in Oslo, Innsbruck, New York, San Francisco, and a couple of other places. And I also run, like, sometimes I freelance and do Dynamo and Revit training for engineering companies and architectural companies around Oslo. So to start off somewhere, I think 2 years ago, I basically started trying out Dynamo for different things, like just playing around with it, seeing how you can do stupid stuff on like sample files on a couple of families and stuff like this. But approximately at the same time, I started using it on projects also. I was working at a time at Dark Architects, another architectural office in Oslo. And this is basically, I think, I was looking through my photos today. This is the first definition that did anything like serious on a project for me with Dynamo. And this was an architectural project, like sort of a competition that we did for one of the rich guys in Norway, a hotel that was supposed to be the tallest building in Norway. We modeled it in Revit with the conceptual massing environment, and then I used Dynamo to create different facade solutions for this project. So this is like walking down memory lane. This is 2 years ago, the first definition that I ever created on a project after playing around with it with Dynamo for a couple of months, I suppose. This technique, or using Dynamo to work on facades, has sort of also become pattern for me. So I think that you'll see many or more examples of this later in this presentation. By the way, the presentation, I'm dividing it in half, basically. The first part, I'll just run you through some images, like looking at stuff that I did with Dynamo on projects. I will not show a single like sample file or tutorial file. This is only project work. And it's both architectural and structural. And then after I go through that, I'm going to show some pretty cool things that I have done at Snøhetta the last couple of months, actually. I'm going to do that live with Dynamo. So I'm really looking forward to that part. But let's look at these projects first. So this definition here would place like a number of randomized panels across a facade on a pretty simple shape. This building was going to be like 160 meters, something that's pretty tall Norwegian standards. And we were looking at different facade patterns. This is a picture of a beautiful model that my friend Olaf Kohn made in our workshop. And this sort of shows you how the pattern, like a sort of a randomized pattern with perhaps more windows closer to human eyes and more like closed spots on the facades around the slab edges and stuff like this. So pretty common exercise, I think, for people to start using Dynamo, do some randomization on a facade, I think is, at least that's what I did. So the first iterations look like these. You know, you go through the I'm not going to, you know, do the Dynamo basics training here. I suspect that a lot of you already are more familiar than me with how Dynamo works and how computational design techniques work and visual programming. And I'm not an expert on this, but I've used it on some projects. So this is like, this facade here uses very, very simple attractor technique. So you place one point in space and then you calculate the distance to each window and then change the window size based on its distance to this point. The next iteration, we used just a simple randomization technique in Dynamo to create different window sizes. And the solution that we ended up using did something similar but different. So we created like 6 different facade modules, all consisting of 6 different sub-modules. Actually more, but yeah, you can see it on the bottom of this picture. You see the different facade modules. This first project was the first time I really started struggling with using adaptive components like on a grand scale. So the first Dynamo definition that I created for this project, I used adaptive components to like randomize the facade, but they become so heavy to work with when you like get more than 5,000 or 10,000 family instances. So I basically went away from working with adaptive components, and I have a feeling you'll hear this point being made several times during my presentation, sadly. But yeah, so we created like completely regular generic model families with materials, parameters, and so on, placed them with Dynamo, did some manual rotation to make it go around the skin, and then just randomized the parameters and types with Dynamo. And it ended up looking like this. I hope it one day will be built. I don't know. So this was like the first serious thing that I ever did with Dynamo. Next up, I did some similar things. This was an architectural competition that we lost at Dark. But also here I used Dynamo to create a randomized facade. Same technique, using like just generic model families. I don't know how you feel about that, but it worked for me. You have to, create some kind of like hidden room bounding elements, so your rooms will be enclosed by the facade, because generic model families don't. So, but when you do that, you can like play around, and when you have like 1 point generic model families in Revit, they are super fast to work with. You can place like thousands of panels like this with Dynamo, and being able to change it without having to take an hour break or going home for dinner, which was actually the case on this first project here when I tried creating like 25,000 adaptive component families with Dynamo. So I'm just going to run through this. After a while at Dark, guy started working there. His name is Thomas Benedict Holt. He's a young Norwegian guy, architect, and it became clear that he was quite familiar with Grasshopper. So this was the start of another series of projects that where I started using Dynamo together with Grasshopper. You'll see this also later in many examples that I'm going to show. So this guy here, he came straight from university and knew about everything there is to know about Grasshopper, about genetic optimization, about analysis with Ladybug, and like all the modeling techniques, all the like the booleans and everything, and he taught me everything I know about Grasshopper. So I think it's really cool when you start from like a BIM perspective, and this guy did stuff like this. So this is showing an architectural competition that we also lost at Dark, sadly. But we used some pretty cool Grasshopper techniques to like sort of try to genetically optimize a building shape based on analysis results. So what you see here is like one of the most busy streets in Oslo, where there's a lot of people walking around the area. So we wanted to create a form that had a decent square meter, like a decent area for the total mass of the building, but also was like kind on the street for not taking away too much sun. So when you're in Norway, you don't want to, you know, steal the sun from people because we don't have that much. And so this is basically running through multiple iterations like options using Galapagos genetic optimization in Grasshopper. And I think the cool thing that we did on this project was that we actually, that was the first time I ever started connecting Dynamo with Grasshopper using a package, the Dynamo package called Mantis Shrimp. I'll show this to you later how this works. Polish guy in New York City, works for Grimshaw. His name is Konrad Soban, and he created a package called Mantis Shrimp. It's in the Dynamo package manager, and you should get it. It basically creates a live link between Grasshopper and Dynamo, so you can like live feed your Revit model with stuff that's happening like this, stuff like this. So I'm going to move on, and this, we ended up with shape that was sort of optimized, but not quite. So something like this. And this is a screenshot from Revit. The form was created in Rhino, sort of using Galapagos and Ladybug, and then live linked through Dynamo to Revit. We had some trouble with this particular shape, actually. If you're using Mantis Shrimp for moving like a form, or a B-rep or whatever from Rhino via Grasshopper to Dynamo into Revit, you're gonna like run into trouble when you want to recreate the geometry in Revit. I'm hoping for this to be better in the future, but basically Revit doesn't really like, you know, these points here. If you can see my mouse, where several lines and forms meet together in like a 0 point, Revit will. So this works better for like, just if you're creating this form in Rhino, export to SAT, import into an in-place mass family, and then you can work like this. But I think we'll see in the future more like live linking data between Grasshopper and Dynamo. I think this is really cool. Next up, I'm going to show a couple of like engineering examples that I haven't worked as an engineer since I started using Dynamo. So the examples that I'm showing is like solely based on training sessions that I did, but it's all based on real projects. And this is my first tests with using the Dynamo for rebar for Dynamo. It's called, I think, the package that Thornton Tomasetti created for Dynamo. So I think this is a super promising tool for creating your own rebar workflow. I don't know how you guys deal with like 3D detailing of rebar in Revit, but in my part of the world, all the engineers have to like detail rebar. This is one of the first tests. I think I have to learn how to use the curve to arcs by parameters that Nathan Miller created, because this is obviously, I just had to take a screenshot because I want to like pull this picture out and put it on my wall. I think it's beautiful. And this also, I think, looks like a pattern. What you're seeing here is really, this is like just horizontal curves that I want to use for creating curved rebar within a concrete form in a pretty complex project that one of the biggest engineering companies in Norway are working on. I'm working with them to help them to be able to use this, because basically, this is actually where we ended up. So basically, if you're familiar with rebars in Revit, if you're an engineer and you ever tried rebars in Revit, you know there's a shitload of showstoppers that will prevent you from operating efficiently. Like if you draw a single bar and you give it a spacing, like to create a rebar set, you can only give that spacing in one direction. You can't have a rebar set follow a curved surface or like have different lengths. And what you're seeing in the background here is basically Dynamo creating line segments along a curved, tilted concrete edge, and then using those curves to generate rebars and rebar container elements within Revit. And this is really cool. If you are an engineer working with rebar, you have to look at this. This will change the future for all rebar modeling, I'm sure. The first tests look like this. This is a project. So Norconsult, biggest engineering company in Norway, they have like a bunch of cool, funny people who are building like an insanely huge hydroelectric power installation below ground. This is like what you're seeing here is like this is like I think 20 meters in this in diameter. A human here would like be very small. So it's huge, and it's all like curved concrete shapes because water is going to run through it, and water doesn't really like 90-degree angle corners on concrete and stuff like that. So it's all like really complex concrete forms, and they want to 3D model every single rebar because the contractors, they want to have a model with a rebar. They don't want to have rebar drawings. They don't want to have rebar schedules. They want to have rebar models with information about shape codes, etc. So here we are trying to use Dynamo for rebar to create rebar elements in 3D along curved edges and so on. And you can see that we're struggling a little bit with the horizontal bars, basically exactly because of what you saw previously, this here. So when we're using intersections, so we have like a shape of concrete, and then we are creating horizontal planes at center distances, like offsetting a horizontal plane from like 0 and up in an array of like 100 or 150, and for each plane you cut the concrete form, you offset the form to like consider cover settings and stuff like this. And then when you have a shape, when you have a surface and you cut it with a plane, you end up with a curve. Now this curve sometimes doesn't really cooperate with you, and that's what you're looking at here. You're looking at like a NURBS curve with like insanely amounts of control points, and that doesn't really work with rebar elements. So the rebar tool in Dynamo for rebar, or rebar for Dynamo, can't remember, it works really well. It will generate all your shape codes with correct parameters like bar segment lengths and everything. But when you're doing curves, they have to be like 100% true arcs. So they can't be like NURBS curves like you're looking at here. So this is something that we have to deal with, and that's basically what you're seeing on this image is some bars are missing. Yeah. So anything that's like, I wouldn't even say like irrational. It's not irrational concrete form. It's super rational. It's curves. But the moment you start having like tilted, curved edges, surfaces with concrete, you are going to have a nightmare doing like manual modeling in Revit. So Dynamo will solve that problem for you if you are starting to get familiar with how it works. So this is basically, just a couple of screenshots of this particular project. Started off here in one of the, well, I'm actually going to say this is one of the easy parts. The other parts of this installation, this like huge concrete installation in the middle of a mountain in Norway, is like super complex. So I can't wait to get started with that. And then that's actually going to cover the engineering aspect of this presentation. I'm going to move on to what I've been doing the last months at Snøhetta. So I started working at Snøhetta. Snøhetta is like the most renowned architectural office, I think, in Norwegian history or whatever. We do a lot of cool projects, and this project is going to be, I hope, the new headquarters of the Le Monde Media Corporation in Paris, France. The shape is kind of interesting, I think. They won the competition like a year ago, so I haven't really worked on this project until just, the last 3 months. I started August 10th, I think. Yeah. I was basically put on the Facade team on this project. I really like the shape. The shape is basically, you see like an arc underneath the building, and that's because there's trains going here. This is really close to a train station in Paris called Gare de Austerlitz. So it's like sort of a bridge building. It's like 7 or 8 floors, and it has like different, it's basically just a blob that we cut with the Boolean operations in Rhino. What you're seeing here is a Rhino model. So we work a lot like this with like shaping in Rhino, and we did on this project also. So this is basically just a blob, and then there's a huge sphere. It's kind of maybe difficult to see the sphere. I'm waving my arms in front of my computer, but I don't think you can see it. There's a huge sphere that's being pushed into this facade that's facing us, and then that sphere is cutting away from the shape, the original shape. So that creates like a spherical facade. That's actually what we're calling this facade, the spherical facade, and it's of course double curved because a sphere is double curved. So this facade I think is really interesting because some parts are tilting, some are straight, some are double curved, the spherical facade, and then there's a nightmare of a facade on the back here. I think this is like my subconscious telling me that I hate the conical facade. The conical facade is a small curved thing that you see in the back, and I'm trying to hide it away because it gives me nightmares. Well, enough of that. So, I guess this presentation is really about it's Dynamo, but I think that for me at least, Rhino, Grasshopper, Dynamo, and Revit is turning into a really powerful combination of tools. And we have technologies to make them talk to each other like super fast and instantaneously. So this is what I'm going to show here. I think that a lot of the things that you'll see me doing in Grasshopper is like, I'm not going to do anything in Grasshopper. I'm just going to show some stuff in Grasshopper, but a lot of it I think could be done in Dynamo. The first facade iterations I did try actually in Dynamo, but this is a pretty big building. We're talking like 25,000 facade panels here also. And I started in Dynamo doing like surface splits, and it becomes really slow. That's also the case in Grasshopper, but so I'm going to show you actually how we developed this facade in Dynamo and Grasshopper. And I have to show you this beautiful picture of a super smart guy that works at my office. His name is Andreas Glatzel. He's in our Innsbruck office, and he really helped us develop this Grasshopper script. So he was basically, and this same thing that I showed with Thomas earlier, you get like a guy on your team and he's awesome at Grasshopper, then I'm not going to force his hand, and you have to do this in Dynamo. And I would rather, have him in Grasshopper do his thing, and then we live link the information to Dynamo, and I can use that information to model in Revit. That works for me. So what you're seeing here now is a screenshot of Rhino and Grasshopper. This is we're starting to panelize the facade, and yeah, and it's pretty cool. I'm going to show you how we work with this on a small section of the spherical facade in just a moment. So this is how it works. So when you install Mantis Shrimp in Dynamo, you are going to go into your folder structures, and first you need to look at Konrad Soban's video on how to install Mantis Shrimp. It's kind of complex, but once you do it like once, you know how to do it the next time. So basically you get like these components to the right-hand side that will live link data or geometry or whatever into a geo file that's just resting on your server or hard drive or whatever. And then this geo file is like just hosting information that Grasshopper is now feeding into it. So this screenshot that you're looking at here takes out center points and vectors from each panel on the facade of the Le Mans headquarters in Paris. And it's feeding these points and angles into different geo files that I'm going to use in Dynamo to create elements. And in Dynamo, it will look like this. So you basically create a family instance by point, you rotate it in different directions if you have a curved or double curved facade or whatever. And then I give each panel like a set of parameters to tell it where it is, on which facade are you an edge panel or not, and this I'm going to show you how to do this right now. So let's see. Yeah, we ended up with something like this. Before we proceed, I think I should tell you how what the goal of the exercise was. So this is just a small corner of the building across 2 levels, and with the spherical facade on the left, the tilted facade on the right, and the straight facade on right in front of us. And we are going to have like 1.35 meter wide glass panels, 6 millimeter thick. They're going to be glued together 2 and 2, and they are going to, that's what we call the mother planks. These are going to be connected to like a steel frame structure that's being connected to the inner facade, which looks like this. So it's a double skin, and you have like mullions here. They're going to carry the steel frames that you see here, and then these steel frames are going to hold the mother plates, the mother planks, which is the double glass. And on these double glass elements, we are going to glue different sized C channel shaped glass profiles. So I'm going to show you how this looks in Revit. The geometry of the families is not like super interesting, but I think it's really interesting how you can manipulate these in with Dynamo. So this is basically what we're going for. And what you're seeing now is a screenshot from Revit. This was created for making a mock-up of the facade that we are currently in the process of doing. And these elements were created with adaptive components. So I would take like all the horizontal cuts, all the vertical cuts where the mullions are on the inner facade, creating like small pieces of surfaces, and then taking the edge points of each surface and creating 4-point adaptive components on these points. And that worked for this small model, but it was super slow. And eventually we had to create this facade for the whole model. So then I went away from adaptive components. I had basically 2 problems with adaptive components. Number 1, too slow. Number 2, extremely difficult to deal with edge cuts. So I spent like a week building these adaptive components to be able to, you know, do the edges, so the edges look good. But this part of the facade is just, it's super simple. So when it comes to more complex things on the bottom and top of the facades, well, I had to go away from adaptive components. So yeah, this is just a close-up of how this looks. And moving to the entire facade, I create bridges between Grasshopper and Dynamo. So Grasshopper is feeding data into a geo file. Dynamo is reading it with Mantis Shrimp and placing families. And this is for one facade. You have the regular panels on top, the edge panels on the bottom, getting different parameters. And then this is a total script. This just looks big, but it's just a copy of each copy of the previous image that you saw. So this will create the entire facade of this project. All geometry coming from Grasshopper. And then we ended up with something like this. So this is a close-up of the same part of the building that you saw, with all the mother planks correctly placed, rotated, and according to the original surface in Rhino, and then also randomized in many different ways with Dynamo. I'll show you how we did this right now. Yeah. I think it's super powerful to be able to do this in Revit, and that was one of the first discussions we had when I started at Snøhetta in August. Is, are we going to do this in Revit, or are we just going to do it in Grasshopper? And we did it in Revit, and I think that being able to work with schedules, like quantifying it, working with parameters, and like moving them manually off also after, where you have a door or whatever, is really cool. So that's the finished results. That's like 22,576 panels. The panels, I'm going to show you the family afterwards. The panel is like an empty panel with the different families hosted, like nested families, all shared. And yeah, so that's the last slide. I'm going to move over how are we on time? Oh, Jesus, this is going way too fast. So this is a project, or one of the Rhino files that we have. This is, I'm hoping you can see my screen updating really fast, like I can. This is the Rhino model. This is the Grasshopper script that's doing one facade. So I'm going to go over here, and I've created like a box within the spherical facade that will just exclude everything that's outside of the box. So we can have, just look at a small section, actually this small section here. So this script here, I'm just going to, this is what Andreas Glatzel did, basically using curves that are coming from Revit, actually. These curves here that you can see at the base, these are mullion placements on the facades. So we're using these could actually also be live linked from Revit, I think, to Grasshopper. In case they change, they're now internalizing Grasshopper, which basically prevents all changes, or I can bake them and change them, but you know what I mean. So I'm cutting this facade with vertical cuts and horizontal cuts, and creating panels like this. And Andreas created like he created this definition so that we could differentiate between edge panels and interior panels, and this really helps when I want to start cutting away at the edges. And then I basically just calculate, get all the points, center points of all panels, center points of all edge panels, angles, calculate angles, and then these are the Mantis Shrimp components. So when you install Mantis Shrimp, you'll go to Grasshopper, Archilab, Mantis Shrimp, and then data export and export. Export is geometry, data export is just numbers, and that's what I'm using for the angles, actually. So I'm moving horizontal. Well, let's look at the vectors. So the vectors have like, I'm calculating the horizontal rotation of each vector and the vertical rotation. And these I need to change the families that I'm placing in Revit. So points, vectors, angles, horizontal angle, vertical angle, being live linked. So the Boolean toggle in Grasshopper is now set to true. That means that whatever I'm doing, we can actually look at these. Yeah, they were last updated in 1948, so yeah. So these are now being live linked into Dynamo. I'm going to open Revit. This is just a sample project. This is not the project that we're working on. And then I'm going to open the Dynamo definition that pulls out all the points and angles from the geo files from Grasshopper. Looks like this. I use file from path to get the live update in Dynamo. And then Conrad created the read GH file, which basically takes everything that's coming from this file and creating like Dynamo points and lines and geometry from it. I'm going to say that Mantis Shrimp works really, really well on simple stuff like numbers and text and points. But when you start looking at like more complex, and it's not like super complex, but like B-reps, sometimes it fails. So what's basically happening here, I get all the points, X, Y, Z coordinates, turn them into Dynamo points, and create family instances on these points. I use the X angles, that's the horizontal angles, and write that data into a family instance set rotation node, and then I use the Z angles. That's I'm going to show you what that looks like. So I have a generic model panel. The family looks like this. The family has, here you can see like the details of what I was describing earlier, like the C profile, and the family has a set of reference lines that will be able to rotate. So when I go to here and rotate this like 8 degrees, the panel will tilt. So I need this for the tilting and the double curved facade, so obviously. So this data I'm changing with a parameter in Revit from my Dynamo script. So I'm getting the Z angles, the vertical angles here, reading this data, and then writing it by an element set parameter value by name node, writing it to a parameter that I've called Z angle. So, and I'm also first, I usually work like this with Dynamo. I divide my definitions in several pieces. So this definition will not change any of the materials. It's just going to place like empty panels. So I'm going to execute this definition now, and hoping, I'm folding my hands here and hoping that it will not crash, because sometimes Dynamo does. And I think that's what you get when you're dealing with beta software, but usually it works. Yeah, there we go. So the Dynamo definition was nice. This group is creating interior panels. This group is creating edge panels. I'm using like a custom node that I just made myself. So that this here will take a file name and then find that it's facade number 3 and it's edge yes. So 1 is yes for edge, whereas the other one has facade number 3 and edge 0. So that way you can write that stuff into a parameter in Revit and look at it and use it in Revit. So basically, this is the facade now, live linked actually from Rhino to Revit. And you can see here this panel is an edge panel. It's on facade number 3, and this panel here is not an edge. So I'm using this to cutting. So we have to. I'm not going to do this now, but I had to like cut each panel, or each actually nested family within each panel, cut it with pretty complex geometry, and yeah. So okay, let's move on. I was trying this right before we started our meeting today, and I had Dynamo crashing on a number of. So I'm going to close Dynamo now and start it again to start randomizing. So I want to start randomizing materials on these panels. Let's see how that looks. Random types. Boom. So I'm pulling out all the families. I'm pulling out the family symbol, and etc. And then let's maximize this. And then I'm using Nathan Miller's lunchbox random split list basically to just create a split. I want to have like a 50% distribution of just empty Mahler planks. This is like this. 66 millimeter thick glass panels glued together, 2 and 2. I want to have 50% of these across the facade, and then 50% of other things, other stuff. So this is basically random split list here will give you, if I use a ratio 0.5, I get 50% distribution, like sort of ish. And then I use the other lists here and do some checks on different things, randomize them, and then change the family to something else. Now let's see how that looks. I'm going to execute the script. Again, folding my hands. This is turning into a habit. Every time I execute a Dynamo script, I fold my hands and I pray that it will work. Voila, perfect. So basically, this Dynamo script is taking all the panels and then telling Revit that 50% these guys and a couple of other guys are going to be just empty glass panels, and then the other guys are going to have a set of different material parameters. So basically, this is just Revit types. I have panels, slimline standard, different types that use different materials and different lengths. So this has one length and this is one length, and they have like, I have used Dynamo now to randomize the placement of these using just different types. So the second or the next randomization that I'm using Dynamo for is flipping the panels, because these families have a flip parameter. Let's see how that looks actually. So I'm gonna take a look at this guy. So it's like, I don't remember if I call this convex or concave, but it's turning in a particular reason. Now I have in this C channel profile glass material, I have a flipping parameter that will just use a different profile. So if I click flip me, it's going to flip the panel. And this is what we want to do, right, randomized across the facade. So I'm going to take Dynamo up again, like this, random flip. And this definition here will just pull out all the families and then flip them. This is like a super simple definition. Again, Nathan's lunchbox random split list it's going to take like list A, and again, we have a 50%, so I want to have half of the panels flipped and half of them not flipped. So then I use 0.5 for ratio, and then we go here and see if we're going to have some split panels up close here, and then use the, and just change the parameter in Revit. The parameter name is flip me, and I'm giving it a value 1. So execute, and then see what happens. Hey, look at you. Nice. I feel the Dynamo is cooperating with me very, very nicely on this beautiful Wednesday night. So now I have 50% of the panels are flipped. Also, the panels that have no like profiled material, but are only like glass plates. So finally, the last part of this exercise, we did some more stuff with Dynamo on this project, but the last thing that I'll show is sort of same-ish thing, because we wanted like we wanted 33.3% of all the flipped panels to be sandblasted on the backside. So I'm going to try to explain this. So this guy should have a 33% of being sandblasted where the C channel material is, where this guy is never going to be sandblasted because he's looking out towards the city of Paris. So in order to do this, again, I just pull out the family types, check out the symbols, get all the families, and then I check if the families have a string contains like an underscore. That will basically tell me that it doesn't have like a profiled material. That's the green, blue, red stuff you see. It's only this guy. And then I'm able to exclude all the families that don't have this material. Like, I think that one of the first things that you have to learn when you learn the basics of Dynamo, you have to learn how to filter stuff with like masks and different techniques. So basically, then I'm using this definition. I'm going to extend this guy. So I'm using this definition to get all the families that have the profiled material glued on each plate, and then I'm getting the parameter called flip me, and I'm asking each panel here basically, are you flipped or are you not flipped? And if the panel is not flipped, it's coming out of this in and not the out. So here you have the flipped, here you have the not flipped. Or was it the other way around? I can't remember. So anyway, the panels that are looking inward toward the building, they are coming out of this output. And then I'm feeding this again into Lunchbox random split list with a 0.33333, like 33, 1/3 of these are going to be sandblasted. So when I now do like this and I execute the script, fold my hands hopefully for one last time this day, we should see some results. Now this can maybe be kind of hard to see, but no, here we see it. So this panel here got a sandblast, and this didn't. This obviously is excluded because it's looking the other way around, and also this panel got sandblasting. So the sandblasting that you're looking at, that's just a super, super, super thin sweep that's being placed on the backside of these plates. Yeah, and that was actually a very short demo of how we did this facade. It finished actually just last week, so this is like super, super fresh material. I think it was a joy to be able to use Dynamo like this together with Grasshopper, the smart Grasshopper guys, and being also able to use the power of the Revit database together with like an awesome visual programming interface for Revit. And with that, I think that we are going to open up for questions. It's 21:52 my time, and it's soon bedtime. So I'm going to finish this presentation now and hear your questions. So go ahead.
Thank you very much, Håvard. I am opening the room for questions. If anyone has something to say, please ask now.
Did you hear or see anything?
Yes.
Good.
Thank you very much, Håvard. I do have a question. Can you reiterate, just in broad description, what was your method for dealing with the edges condition? That's something that we all struggle when it comes to testing facades.
I'm sorry. Could you please repeat how I dealt with what?
How do you deal with trimming residual panels at the edges of the facade? You know, with adaptive components?
No. So, yeah, my first tests were actually with adaptive components, but I had to go away from adaptive components because I could basically, well, it's really hard to work at a decent speed with adaptive components when it comes to this amount of panels. Like I said, 22,000 panels. So I needed to, I'm going to show this picture actually. Yeah, this shows that, like, and this more up close. So basically what we did is that when all these definitions were finished and the facade was finished, you had overlapping panels at the edges. And in Rhino, we used the edges of the surface, extruded the edges and created like forms, huge forms along the edges. And then I exported these forms as SAT files, put them into a family in Revit, made sure that they were voids, and then I placed the families inside my project environment, and then I used Dynamo to cut all the nested families from the voids. Yeah, it was really difficult. But if you look at Julien's custom node called Steam Nodes, he has a couple of nodes there, a workflow actually for being able to use void families in Revit and batch cut with cut geometry tool, basically. And this is what I did. Yeah.
All right. Thank you. Does anyone have more questions? Let me check online and see if anyone wrote the.
Okay, so Jeremy Lubker is asking, what was the name of that mass cut tool? I can see if I can find it. I think I have Steam Nodes installed on this computer. Yeah, Steam Nodes tool. It's called add void cut. Yeah, and get surrounding elements. So I guess maybe I can. I think these two nodes you are using to like batch process a cut geometry operation in Revit. Basically, the problem that you're having with like generic Revit is that the cut geometry operation within Revit, if I can access my modify tab, when you click cut geometry, Revit says you should click the element to be cut first. So then you have to like tab into your nested family, like click this guy and then click the void. And then you click this guy and click the void. And then you sit like this for 2 weeks and you missed your deadline and everything. So Dynamo will do this for you automatically.
I have a question for you.
Anything else? Yeah.
So on the last example you showed with the different panels, it looks like you're utilizing a variety of different generic families, and you're basically sandwiching all of those elements together. That's a lot of faces for Revit to handle. How was the overall project performance just in Revit alone?
Well, the project performance was okay. This is one of the most complex Revit models I have ever worked with, and the facade certainly didn't help. I have to blame myself also. I shot myself in the knee by adding these like round corners of the glass, which is completely useless for anything, but it made me feel good. So you should really avoid stuff like this. That will hurt. And also, and Conrad Soban seriously warned me against using Dynamo like mass cutting. When you create like 8,500 cut geometry operations from between a huge void and like a million nested families, it's going to bloat your file. So you will have a bigger file size when Revit has to remember all these cut operations, because they're live. So if one void family disappears, the cut disappears. If it moves, the cut moves. So yeah. So it was okay. I think if the project had been bigger, we would have trouble. But this was okay. So,
right,
any other questions?
There's one on the chat panel, if you can read, is what was the facade structure? Was the facade structure built independently from the panel?
I'm sorry, could you please repeat?
Yeah, so this is a question from Benjamin online. It is, was the facade structure built independently from the panel?
The facade structure, so I'm guessing that Benjamin is thinking about the structural system of the facade, like how the facade was being carried. And if that's the case, then I'm saying yes, it was what you're looking at here. This like the most outer skin of the facade was in a completely different Revit model. We just had to like create it in a separate Revit model and then link it where necessary. And the structure of the facade, like the inner facade with the vertical curtain walls, like with the mullions and all the steel profiles carrying this outer skin, was located in a separate model, which was like the main architectural model. Yeah. I actually also use Dynamo to create the vertical framing elements, because it's a pain in the somewhere to like model curved beams in Revit manually. So this spherical facade has like a bunch of curved steel T-sections that are following the surface, and I use Dynamo for that as well. And you also use Dynamo to auto-number like 650 rooms in the project based on level, department, and grid location. So wasn't space for that in this presentation, sorry.
I have one last question for you. Have you done any work with panel optimization to be able to reduce the number of varying panel sizes for prefabrication?
No, sorry, I haven't. I have like a couple of points in my plan for the future, and one of them is definitely learning more about optimization. I want to learn how to use Optimo and Dynamo. I want to really learn how to use Galapagos and Grasshopper and the other tools. I think there's several like optimization technologies available for Grasshopper. But no, sorry, I haven't done that yet in Dynamo. No.
Right. Nobody else have a question? All right. Why don't we give an applause to Håvard for his time?
Well, this is the first time I actually hear that there's a lot of people there.
Well,
thanks.
I wish we had a camera so you will see our faces. Thank you very much for sharing your knowledge with us. Your presentation will be made available to the public via our YouTube channel if you want to catch up on a later time. And we really appreciate for your time. The work you've done is fantastic, and I'll proceed to close the session.
Thank you, and thanks so much for inviting me. This was a great way to spend my Wednesday night. And if any of